In this video, we want to learn about sigma notation, and we want to learn how we can use it to write sums in sigma notation. Look at this sum, a1 plus a2 plus a3 up to an. We want to add these terms to each other. We can write this sum in a shorter notation with the aim of the sigma notation. Sigma notation is like this. This is notation of sigma, which means that we want to add something. So this notation is adding or summing terms. So sigma is adding. What we want to add here? We want to add a1, a2, a3 up to an. So here in front of the sigma we have to write a k, which k starts from 1 and it goes up to n. So in this notation the sigma is adding the terms, the notation for adding. The k starts from 1 because it tells us that we want to start from 1, a1. Attention, if we plug in 1 here, then we have a1. And we want to continue adding up to an, so the n on top of the sigma notation shows the end or the last term that we want to add. If we want to get more familiar with the sigma notation, we have to do some examples. Look at the first example that here we have. Sigma, which means add. What we want to add here, k, which k starts from 1 to 4. So this notation basically means that first we have to plug in 1 for k, because k starts from 1. So we plug in 1 for k. After 1, what number we have? 2. So we plug in 2 for k. Then we have 3, and the last number that we want to add is 4. So this notation here is exactly shows this sum. So sigma k from 1 to 4, so basically we have 4 terms, and those terms are 1, 2, 3, 4. What is this sum? 1 plus 2 plus 3 plus 4 is 10. So the sum is 10. Now look at the next example. Sigma I from 1 to 3 of I to the 2. This sum shows 1 to the 2. Attention, we start from 1. We substitute I with 1 because I starts from 1. After 1, what number we have? 2. So 2 to the 2. Then we have 3 to the 2. 4 to the 2. But attention, we have to end at 3. So the last term that we add is 3. So in here we have only 3 terms because I starts from 1 to 3. 1 to the 2 plus 2 to the 2 plus 3 to the 2 is 14. If you add these numbers, 1 plus 4 plus 9 is 14. Look at the next example. Sigma j from 2, and attention, this k can be sometimes I, j, but most of the time we have I, j or k in the sigma notation. And this I or j or k or whatever it is the index of summation or variable of summation. Usually we say index of summation. So in this notation, the k is the index. In this notation, I is the index. Here j is the index. And index is the variable that we have in our summation. Please look at this sum here. The power is all the same because it's 2. But I changes from 1 to 3. So the index or variable of summation or variable of the sigma changes in between the terms. Look at the next example. Sigma j, which j is the index, from 2 to 4. So here the sigma starts from 2. Usually in most of the examples that we will see, the index of summation starts from 1 or 0. But here j starts from 2. So what terms we have to add? First we plug in 2 for j. Then we have 1 over 2. After 2 we have to plug in 3. 1 over 3. And the final term is 1 over 4 because the last value for the index is 4. 1 over 2 plus 1 over 3 plus 1 over 4. We have to add these terms to each other. To add these fractions, simply we have to do a simple common denominator. Between 2, 3, 4, the common denominator is 12. So if we consider 12 as the least common multiple, because we multiply this by 6, we have to multiply numerator by 6. 3 times 4 is 12, so we multiply numerator by 4. 4 times 3 is 12, so we multiply numerator by 3. 6 plus 4, 10 plus 3, 13 over 12. So the value of this sigma, the sum of all the terms of this sigma, is 13 over 12. Now look at these examples. In the first sigma, we have 2i minus 1 and I from 1 to 3. So the index of the sigma starts from 1. We plug in 1 for I. If we plug in I, 1 for I, then we have 2 times 1, 2, minus 1 is 1. So we plug in 1 for I and we calculate the value of the general term of the sigma. Then we have 1. 2 times 1, 2, 2 minus 1, 1. What is the next term of this summation? If we plug in 2 for I, if we plug in 2 here, 2 times 2 is 4, minus 1 is 3. If we plug in 3, which is the last value of the index, 2 times 3 is 6, minus 1, 5. So these are the terms of this sigma. 1 plus 3, 4, 4 plus 5, 9. And this is the sum of this sigma. Please pay attention. Maybe at first it doesn't seem important, but later you will see that this is really important. Here, for the index of the sigma, which is I, we have a coefficient 2. If you pay attention, the difference between these values that here we have is exactly 2 units. Because here we have 2i, this 2 multiplies by I. The values of the index of the sigma increases every time 1 unit. But here, because the I is multiplied by 2, as you can see here, the increase in the amounts that here we have is 2 units. So if the increase is 3 units, then we have to have 3i. For example, if in a sigma we have something like 5i or plus minus something, the increase in the terms of that sigma would be 5 units. Keep this in your head. Later in the video, we will see that this is really important thing to know. Look at the next example. Here, this is really interesting. We don't have any I or any J. The index is J. We don't have any J here, which means that the terms of this sigma are constant. Please pay attention. We don't have any J to substitute with 1. So what is the first term of this sigma? As you can see, it is 4. When J is 1, we don't have any J to substitute with 1. So the first term of this sequence is 1. When J is 1, the first term is 4. What is the second term of this sigma? When J is 2, what is the second term? It's again 4 because it's always 4. So this sigma is 4 plus 4 plus 4 plus 4 plus 4. Because this is always constant. It doesn't change. When J is 1, this is 4. When J is 2, it's also 4. J is 3, it's 4. How many 4s we have? We have to add 5 because J goes from 1 to 5. So we have in total 5 terms. All these terms are 4. So the sum of the terms is 20 because 5 times 4 is 20. In general, let's say we have a sigma I from 1 to m. And suppose the term is just C. What is this sum? As you can see here, in the term that here we don't have any I. So all the terms of this sigma are C. So basically, this sigma shows C plus C plus C forever up to the last term, which is m. So we have to add C. How many times we want to add C to itself? M times, because I goes from 1 to m. So in total, m times we add C to itself. So what is this sum? MC. For example, if m is 10, the sum is 10c. If m is 20, 20c, and so on. So this sum here is m times c. Let's do the next example that we have. Look at the next example. K is from 0. So first we plug in 0 for k, which is the index of the sigma. Then we have x to the 0. Any number other than 0 to the 0 is 1. So the first term is any number to the 0 is 1, except 0 to the 0, which is undefined. So x to the 0, if we suppose x is not 0, is 1. So the value of the first term of this sigma is 1. What is the next term? X to the 1. What is the next term? X to the 2. And we have to continue up to the x to the 4. So the only term that I have to write here is x to the 3. So this sigma basically shows 1 plus x to the 2 plus x to the 3 plus x to the 4. And basically this sigma shows the sum of the terms of a geometric series. But this is not the topic of this video. Here in this video we want to learn about the sigma notation. Look at the next example. Sigma I from 1 to 2024, negative 1 to the k. First of all, this sigma shows the sum of how many terms? Because I start from 1 to 2024, so in total we have 2024 terms. But what are the terms? If we plug in here, it should be k, not I. This is k, not I. K goes from 1 to 2024, negative 1 to the k. If we plug in 1, then we have negative 1 to the 1. Then we have negative 1 to the 2, negative 1 to the 3, negative 1 to the 4, negative 1 to the 5, and so on, and we continue up to negative 1 to the 2023, and the last term is negative 1 to the 2024. Now if you pay attention, negative 1 to the 1 is negative 1. Negative 1 to the power of 2, because the power is even, would be 1. The next term is again negative 1. The next term is positive 1, negative 1, positive 1, and so on. And this pattern continues up to negative 1 to the 2023 is again negative 1. Negative 1 to the 2024 is again 1. Because the sum of each two consecutive term is 0. These two, the sum of these two is 0, the sum of these two is 0, and this sum of these two is also 0. So the total sum is 0. Now so far you should be a little familiar with the sigma notation. Now that we are a little familiar with sigma notation, let's see how we can write the sums using sigma notation. Now we want to do the opposite. We have a sum and we want to write it in the sigma notation. Look at the first example. We want to write this as a sigma notation. First we write the sigma notation and we consider an index. You can choose I, j, k, whatever you like. I am using I. As you can see, I starts from 1 and it goes up to 10. I from 1 to 10. If you pay attention, we have 10 terms, so I from 1 to 10 makes sense. Now look at the terms. If you pay attention, in all of these terms, the power is always 2. So the power is 2. It doesn't relate, it's not related to I. So I put a power 2 here. Now, this box, as you can see, changes. It's 1, then it is 2, then it is 3, then it is 4, and finally it is 10. What is that box? That box is the index of the sigma. So here we have to write I to the 2. When I is 1, we have 1 to the 2. Then I is 2, 2 to the 2. Then I is 3, 3 to the 2. And finally, the last term is 10 to the 2. So this sigma shows this sum in a shorter format. Let's do the next example. I highly recommend you to pause the video here, try to do this example by yourself, then continue watching the video. Again, first we put a sigma here. Because it starts from 1, so we start I from 1. You can use j, k, whatever you like. I starts from 1 and it goes up to 99, so 99. As we can see, we have a square root over every single term, so we have to have a square root. And inside the square root, it's I, because it's changing. It's 1, then it is 2. It's not constant. 1, 2, 3, 4. And it is the role, it is the job of I to do that, because I changes from 1 to 99. So we can write this sum in the form of sigma radical I from 1 to 99. Look at the next example. Again, it can be a good idea to try this example by yourself. Sigma I or j or k, whatever you like. Here let's use k, why not? K starts from 2 to 10. As you can see, every single term has a log, so log of k. And when k is 2, log 2. Then k is 3, log of 3. Then k is 4, log of 4, log of 5, and now finally we continue up to log of 10. Let me explain something to you here. It's very important. Please pay attention that there is no unique way to represent or write a sum in sigma notation. This is your answer. Maybe the answer of another person is, for example, another person uses k, instead of k he uses I or j. The other thing is that it's not necessary that you start the index of the sigma from 2. Maybe you like to have a sigma that starts, the starting point is not 2. Like the other examples, maybe you like to have a sigma that starts from 1 or even 0 or other numbers. Can we change the starting point of a sigma from other than 2 here? Or what about this? Can we write this sum in another way? Yes, there is a way that we can change the starting value of a sigma notation. Let me show you how. Suppose you don't like this sigma notation here for this sum, and you prefer to have a sum, a sigma that starts from, for example, 1. If we want to change this from 2 to 1, what we have to do? Of course, you have to change something here, but how we can do it? Please pay attention. Instead of this, you have to write sigma k from 1. You can change it from 2 to 1. Okay, what has happened here? Please pay attention. 2 is changed to 1, so you subtracted basically 1 unit from k here. Because you have subtracted 1 unit from this index. First of all, you have to subtract from the upper bound also. Because when k goes from 2 to 10, in total, if you pay attention, you have 9 terms. 2 plus 3, 2, 3, 4, 5, 6. If you count how many terms you have, you will see that you have 9 terms in total. Here the starting point is 2, so it goes up to 10 because you want to have 10 terms, 9 terms. So if k starts from 1, it should continue up to what value? 10? No, because if you continue k from 1 to 10, then you have 10 terms. What you want to have? 9 terms. So the first thing that you have to change here is that if you want to change the value of the starting value of a sigma from 2 to 1, because you subtracted 1 unit from this, you have to subtract 1 unit also from the end value of the sigma. So you have to change 10 to 9. This is the first thing that you have to change. So far we have learned how to work with a starting value and the ending value of the sigma. 1 to 9. What about this? Should we keep it the same? No, of course not. Because if you write log k, why it doesn't work? Because now if you plug in 1, then you have log 1, which we don't have here. And if you plug in 9 here, the n would be like 9, but we want to have like 10. So how we can fix this then? Because, please pay attention, this is really easy. Because you subtracted 1 unit from this, you have to do the opposite of this operation to the k here. You subtracted from k, so the opposite of subtracting is adding. So you have to add 1 unit to k. So to fix this, simply here you can write log k plus 1, and then everything is right. Let me show you why. Now if you plug in 1 here, 1 plus 1 would be 2, you have log 2. Then if you plug in 2 here, then you have log 3. And finally, if you plug in 9 here, you have log 10. As you can see, these two are two different format or ways to show this sum with sigma notation. And they are completely different form. They are the same. They show the same sum, but they seem to be different. One of them starts from 1, ends at 9. The other one starts at 2, ends at 10. Let me show you, for example, how we can do this for this example here. Suppose you like to write this in another format. For example, suppose you want to write this in the form of I from 0. And because you start from 0, you subtracted 1, the upper bound would be 98, you subtract 1. And because you subtracted 1 from I, you have to do the opposite with the I here, I plus 1. Look at this example. Suppose here, for some reason, you prefer to start I from, for example, 5. Because you added 4 units, so you have to add 4 units here. 10 plus 4, 14. And what should happen to I? The opposite. You add it to the value of I. You add it to the starting value, 4 units. So you have to do the opposite. Subtract 4 units from I. So I minus 4 to the 2. So this sum here shows exactly this. For example, if you plug in 5 here, 5 minus 4 is 1. 1 to the 2 is 1 to the 2. If you plug in 6 here, 6 minus 4, 2, 2 to the 2 is 2 to the 2, and so on. So there is no unique way of writing a sum in sigma notation. Now look at these examples. 1 plus 3 plus 5 plus, continue up to 99. So we have to write a sigma. It seems that it starts from 1, so maybe we think to start I from 1, but there is a problem here. The values of the sum that here we have do not increase 1 unit by 1 unit. 1, then suddenly 3, 5. It increases 2 units, not 1 unit. Whenever the difference between the values of the consecutive terms that you have is other than 1, then you should not write I. The difference is 2 units, so you have to write 2I. If the difference is 5 units, 5I. If the difference is 4 units, 4I. So here, the difference is 2 units. This is like arithmetic sequence or arithmetic series. The difference is 2 units, so you have to write 2I. So here in the sigma, we are going to write 2I. But if you write 2I, if you plug in 1, 2 times 1 would be 2, but you want to have 1, not. And if, for example, if you plug in 2, then you have 4, but if you want to have 3. How we can fix this then? 2I minus 1. This fixes everything. Let me show you why. When I is 1, 2 times 1, 2. 2 minus 1, 1. Now let's see what happens if we plug in 2 for I. If you plug in 2, 2 goes here, 2 times 2, 4, 4 minus 1, 3. If you plug in 3, 2 times 3, 6 minus 1, 5. So everything works. Now we have another problem. What is the end value that we have to write here? Is it 99? No, of course not. Because if we plug in 99 here, 99 times 2 would be 198. Minus 1 would be 197. But we want to have 99. One way to figure out this value here is to attention that we want at the end to have this equal to 99. So you can set 2i minus 1 equal 99, then solve this for I. 2i equals 100, add 1 to the both sides, then I is 50. 100 divided by 2. This is one way to figure out the end value, the upper value for the sigma, which is 50. But is there any other way? Yes. The other way is to subtract this from this 99 minus 1, then divide it by the common difference. What was the common difference between the terms? Between 1 and 3, between 3 and 5, or between 5 and 7? What is the common difference? 2 units. So divide this by 2. 99 minus 1 divide. So last term minus first term divide by common difference plus 1. This is the rule that you can find the number of the terms that you have in your sigma. 99 minus 198. 98 divided by 2, 49. 49 plus 1 would be 50. This is the other way that you can use to find the number of the terms in a sigma if it is complicated like this. There are other ways like using arithmetic sequence method, but these methods that I showed you here maybe are easier to use to find this value here. Let's do the next example. Here also we have a tricky question. We want to write this as a sigma, so we write this sigma. Usually we prefer to start I from 1, so let's start with 1. Now let's see what's happening here. If you pay attention, the common difference between the terms is 5 units. 5, 5, plus 5, plus 5, plus 5, and so on. So we notice that we have to write 5i. But it's clear that 5i doesn't work, because if you plug in 1 here, 5 times 1 would be 5, but we want negative 1. How we can fix that? We have to subtract a value from 5i. Because when we plug in 1, we have 5, but we want to have negative 1. What number I have to subtract from this that gives me negative 1? 6 units. 5 times 1 minus 6 is negative 1. So we can write this in the form of 5i minus 6. But let's make sure that this is right. If we plug in 1, it is right. What about 2? If we plug in 2 here, 5 times 2 minus 6 is 4. If we plug in 3, it should be 9, which it is. So our formula is right. Now let's see what is the value that we have to write here. Again, you have two methods. You can set this equal to this, solve it for I, then you can find this value. This is one way. 5i minus 6 equals 999. If we add 6 to the both sides, 999 plus 6 is 1005. Divide both sides by 5, then I would be 201. So it is 201. The other way, last term minus first term all over common difference. Common difference is the difference between these values. Common difference is 5 plus 1. This is 1000 divided by 5, 200 plus 1, 201. These are two methods that you can use to find the number of the terms in questions like this. But attention, this method works when we have constant difference between the values that here we have to have constant difference, common difference. Now look at these examples. These are little advanced examples that we want to do. 1 plus 2x plus 3x to the 2 plus 4x to the 3 and so on up to 100x to the 99. The first thing that here we notice is that we have one extra variable, and that is x. We have numbers that are changing 1, 2, 3, 4 and so on, but x is the new thing here. What we have to do with that? Just write it as x, because it's not related to, it's not a variable, it's always x, 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 x. So don't worry for that. Look at this. It should not be too complicated. We write a sigma. As usual, we prefer to start I from 1. And if we suppose this shows I, first I is 1, then it is 2, then it is 3. There is no jump, nothing to be worried about, no jump. The common difference is always 1 unit, 1 unit, 1 unit increase. So I goes from 1 and it seems up to 100, because in total we have 100 terms here. So far it's so easy. Then we say we have a coefficient, then times x, a coefficient times x to a power and so on. So first thing that we notice, we have to have x in the term that here we have to write. But there is a power here and a coefficient here, if you pay attention to, if you look at all of this. Maybe you are worried about this because it doesn't have any x. But focus at the other term, then we will go over that term. So if we, for a moment, we ignore this, focus on these terms, what do you see? You can see that if we consider, for example, here, whatever is here, the power here is 1 less. 2 power is 1. 3 power is 2. So, if, please pay attention, if the coefficient here is I, what is the power? Here is 3, here is 2, 4, 3, 199. I minus 1. Now let's see this formula for this works or not. First of all, if we plug in 100 here, then we have 100x to the 100 minus 199. So it works for the last term or the final term of the sigma. But what about this? If we plug in 1 here, let's see what happens. Then we have 1x to the power of 1 minus 1, which is 1x to the 0. Any number to the 0 other than 0 is 1. So 1 times by 1 is 1, which it should be 1. And that's it. So it seems that our formula works perfectly. Let's see what happens if we plug in 2 here. Then we have 2x to the power of 2 minus 1, which is 2x. Now, let's do the next example. In this example, again, we write a sigma I from 1. If you pay attention, we have one term here, which you can consider right now. You should be able to understand this is like x to the 0, then we have x to the 1, then we have x to the 2, and it goes up to 50. So because we start from x to the 0, x to the 1, x to the 2, maybe you think to change this from 1 to 0 and up to 50. It's up to you. You can do it that way as well. But for now, let's start I from 1. Then I will show you, if you want to start I from 0, how you can do that. Let's start I from 1. Then let's see what we have here. The thing that we notice is that we have x to the 1, x to the 2, x to the 3, x to the 4, so x to the I. But I doesn't work, because if we write I, when we plug in 1, then we have x to the 1, which is here. But what about this? We want to start from this. So the first term is this, which is x to the 0. So if we write x to the I, this is not right, because we miss this term. How we can fix this? You have two choices. Either change this to 0, then this covers x to the 0, which is this term. The other way is to subtract 1 from I. Let me show you this way, then I will show you the other way. So let's fix this. We fix the power and we change power from I to I minus 1. Now look at the denominator. As you can see, in the denominator we have a different story. And attention, this is like 1 over 1. 1, 3, 5, 7, and so on. What do you notice? A common difference. What is the common difference? 2 units increase, 2 unit increase. So in the denominator we have to write something like 2i. But is it 2i or we have to change it? Of course we have to change it. 2i minus 1. The reason that we have to subtract 1 is that when we plug in 1, we have 2 times 1, 2, but here is 1. We subtract the 1, then we have 1. Now if we plug in 2 here, 2 times 2 is 4, 4 minus 1 is 3. So now everything is right. But we have still one problem here. What is that? Here we can notice that the first term is positive, the next term is negative, the next term positive, negative, and so on. How we can fix this? Probably you are familiar with this sequence, negative 1 to the I. The terms of this sequence are negative 1, then 1, negative 1, 1, so alternatively positive, negative, and so on. And the starting value is negative. But here the starting value is positive, then negative, positive, and so on. How we can fix that? If you change negative 1 to the I to negative 1 to the power of I plus 1, then this is exactly what we need for this. So whenever you have alternative terms that become positive, negative, and so on, in your expression that you write for your sigma, you have to write a negative 1 to the power of I or I plus 1 or something like that. So in our sigma notation, we have to multiply this by a negative 1 to the power of, let me write this in a better way. So we have basically this negative 1 to the power of I plus 1 or minus 1, both of them works, x to the power of I minus 1 all over 2I minus 1. Let's make sure that our formula works perfectly. What about the upper bound? We forgot this. What about here? How many terms here we have? If you pay attention, we start from x to the 0 and we continued up to 50. 0 to 50 is 51 terms. So it is 51 terms. The other method is, do you remember the method? Set this value equal to this, solve it for I. 2I minus 1 equals 101, 2I is 102, and I is 51. Now let me show you how we can write this sigma in the form of a sigma that I starts from 0 and goes to 50. Because we subtracted 1 unit from here and 1 unit from here, so what we have to do with the i's here? The opposite. When we subtract from our index, we have to do the opposite of that operation with the index of the sigma. So what we have to do here? We add 1 unit to the i's that here we have. Please pay attention. This is a little tricky. Many students cannot do this in a right way. Please pay attention. We subtracted 1 unit from this index. The opposite of that is to add 1 unit to the I. So you have to replace the i's with I plus 1. So then we have negative 1 to the I plus 1. There is a reason that I'm putting a bracket for this, plus 1. I is changing to I plus 1. Let's do it for the other I. X to the power of I plus 1 minus 1. Maybe you wonder why I am putting bracket for I plus 1. Because I plus 1 without bracket or with bracket doesn't matter, it's at the end the same, but it's important for the denominator. 2 times I plus 1 minus 1. Here you can see the importance of that. If you forget to put bracket, then you forget to multiply 2 in the bracket and it would be completely different answer, which would be wrong. Now let's simplify this answer. If we simplify this, the final answer is sigma I from 0 to 50 negative 1 to the power of I plus 2 times by x to the power of I, because I plus 1 minus 1 is I. What about denominator? If we multiply 2 in the bracket, we have 2i plus 2 minus 1, which is 2i plus 1. Maybe some of you prefer this new answer, which is basically the same answer as before, but because it's maybe a little, seems at least a little better, maybe you prefer this answer to that answer. Before we finish this video, let me explain something about here for you. Negative 1 to the I plus 2 is basically negative 1 to the I times negative 1 to the 2. We can write it this way. Negative 1 to the 2 is 1. So negative 1 to the I plus 2 is the same as negative 1 to the I. So we can write this sigma here in a better way. So this equals to sigma I from 0 to 50 negative 1 to the I x to the I over 2i plus 1. So at least for me this seems a little better than this answer. I prefer this answer to this answer, although both of them are completely right. I hope by watching this video you have learned about sigma notation and how to write sums in sigma notation. If you liked this video, please subscribe to my channel and see you in the next videos.